Hello everyone, I am Prudhvi Atluri, Data Solution Architect with Conf42. So I have over 10 years of experience in designing cloud native analytics platforms for several different customers, specifically on AWS. And in working with customers from different domains, I've repeatedly seen a common pattern, which is services are often were misapplied. So specifically when it comes to observability, it leads to a lot of bad outcomes, which is it leads to blind spots, alert fatigue, ballooning costs, and mistests. So today at Conf42, we will keep it at a very high level and focus mainly on real-world monitoring and observability use cases. In today's cloud-first managed services promises agility, scalability, and reduced operational overhead. And these services have become the foundation of modern digital and data architectures, and the ease of adoption often masks a very critical risk, which is a misalignment between the service capabilities and actual workload requirements. So when cloud services are selected without clear understanding of their intended function in context, they can definitely introduce long-term friction, and it costs teams valuable time, capacity, and financial resources. So by the end of this session, we will have a clear mapping of requirement, tool choices, so that we never over or under provision our telemetry stack, and a decision framework that will help us weigh latency, complexity, and granularity, and best practices and common pitfalls to watch out as we build and optimize our observability layer in AWS. So what is observability? So observability is nothing but the measure of internal state of the system by examining outputs such as logs, metrics, and traces. It's not about just monitoring, it's about deep insight and understanding the system. And its main purpose is to empower teams to detect, diagnose, and resolve issues faster. So it helps improve reliability, performance, and user satisfaction. So when it comes to cloud platforms, cloud and data platforms, we have a lot of microservices, serverless functions, distributed pipelines, and observability is a connective tissue that holds the modern data architectures together. So without it, blind spots emerge, lead to increasing downtime, user frustration, and loss of trust. So from a strategic standpoint, observability is the foundation for cloud analytics platform, and it enables real-time decision making, compliance assurance, and proactive optimization. So here are some core pillars of observability. So one is logs, second is metrics, and third is traces. So let's understand each one of these. Logs are nothing but immutable records of events that have occurred within the system, such as error messages, user actions, state changes. Logs provide granular time-stamped context and are vital for post-incident analysis and auditing. When it comes to metrics, quantitative measurements taken at regular intervals. For example, we take CPU usage. So it's a quantitative metric that 80% is utilized. Memory, it's a quantitative metric. Request counts, error rates, right? These are all something we call metrics. And these are compact and efficient for trend analysis. How's the CPU utilization over time? How's the performance over time? So this is something the metrics are going to be really helpful in such scenario. And the last one is traces. So traces show the journey of a single request, for example, across various services. So it captures the latency. And this is very critical for understanding complex and interconnected systems. And it will definitely help with the root cause analysis. So let's understand some of the core services in AWS. The very first one is CloudWatch. So when it comes to capabilities, it is used for log collection, metric aggregation, customizable dashboards for alarms and automated actions, The general use case is general purpose monitoring, alerting, and automated responses. So CloudWatch is a foundational observability tool provided by AWS. So it will allow us to gather all these logs, metrics, and define these dashboards. We will also have an ability to configure custom alarms, proactive alerts, and automated remediation. So it's a versatile and integrates seamlessly across various AWS services, making it very ideal for monitoring and basic troubleshooting. So when it comes to X-ray, end-to-end tracing requests through distributed application, detailed insights into microservice interaction, and it's mainly used for debugging and performance optimization of these microservices. So we can understand which microservices is taking more time versus the one that is acting up very quickly. So it's a very helpful service and offering that AWS has. So the next one is the managed Grafana. Capabilities wise, it's very rich in terms of visualization. It provides seamless integration with multiple AWS services as well as multiple open source databases. It will provide real-time dashboards and analytics. So majorly this managed Grafana is used for real-time visualization of system metrics and logs for operational insight. The next one is a BI offering. So QuickSight, it's called QuickSight. It's a very popular tool, and the capabilities are it's a BI service offering. It's not really an observability tool, but it provides interactive dashboards, insightful analytics, and natural language query processing using QuickSight Queue. So the use case wise, it is used for business intelligence and analytics reporting with periodic data refresh. It's not real time though. The last one is restore for open telemetry. So capabilities include standardized instrumentation and data collection across various platforms. So it's a vendor neutral broad compatibility. So it provides a unified observability across diverse application stacks. So here is another list of expanded AWS observability tools. The first one is CloudTrail. So CloudTrail audits every API action in AWS account, essential for governance, compliance tracking, and tracking changes. So it logs any unauthorized attempt to access something, or it keeps a log of various services interacting with each other, or the users trying to access certain services. It will try to keep track of all those actions. AWS config, on the other hand, continuously monitors the resource configuration. It ensures adherence to the regulatory standards. And DevOps Guru, it uses ML to detect anomalies in the application, suggesting root causes and remediations. It's a very helpful tool. And Trusted Advisor, it evaluates our AWS setup against best practices for cost, security, and performance, and provide recommendations. Compute Optimizer, so it recommends the most efficient compute, a resource based on our usage patterns. And finally, Inspector, it automates the security scans on EC2, Lambda, and container workloads. So let's understand now some architecture patterns. Centralized telemetry pipelines. So we collect, store, process observability data from various sources in a centralized manner using services like S3 and OpenSearch. And when it comes to real-time monitoring, so let's say if you want to enable live dashboards and alerts using tools like Grafana and CloudWatch for immediate visibility into system performance. In this scenario, like Grafana and CloudWatch stands out. Along with that, we can use multiple other services which can be easily integrated to send notifications like SNS, SES, etc. And for AI/ML integration, so it's recommended to leverage AWS SageMaker and Bedrock to apply machine learning models for predictive analysis on automated diagnostics and anomaly detection. So for automated response, implement automated remediation and scaling using AWS Lambda and EventBridge. It will help us quickly address issue and maintain reliability. As it is mentioned, a robust observability architecture centralizes the data, powers real-time monitoring, and leverages AI and automate the response for resilience and scalability. So now let's understand what is function and what is friction. So it's a framework that we should keep in mind when selecting cloud managed services. And it's very important to follow this approach, right? So function is when tools we pick accelerate insights and integrate seamlessly at scale. So the tools empower teams by providing clear, fast, and aligned insights. On the other hand, friction is when tool introduces the noise, lag, and complexity. So it often hinders team ability and causes delays and confusion and ultimately higher costs. So looking through function versus friction lens, it will help teams to choose observability tools that drives the operational excellence by maximizing the insights and minimizing the complexity. Now let's take a look at the examples of function. So the very first one is using CloudWatch alarms for real-time alerts. So it's a very good function. So it's recommended and best practice to use CloudWatch to collect metrics, logs, and visualize the data using CloudWatch data dashboards. And we can also have trigger alarms for easy to monitoring Lambda metrics, container insights, and cost tracking. So it's a very helpful tool in this context. CloudWatch definitely adds a function, and whenever we have such use case, it's recommended to go with CloudWatch. And the next one is X-ray for pinpointing service bottlenecks. So let's say we have a web of microservices that are, and we don't know like what is taking more time. So in such scenarios, X-ray provides distributed tracing for microservices, and it will help us debug the performance issues, traces API gateway, Lambda flows, and visualize the service maps. So it's a great tool and it will help identify bottlenecks very easy. So it's another example of function. And my favorite one is Grafana dashboard for live performance views. So not only just for observability, but for monitoring, IoT, many other use cases. So Grafana or managed Grafana enables live dashboards from CloudWatch, Prometheus, and several data sources, you can name it, used in NOCs, SLO tracking, service level objective, and anomaly detection. And open telemetry for unified instrumentation. It provides standardized instrumentation across applications like ECS, EKS, or hybrid environments, sending data to CloudWatch or third-party tools. So these tools overall reduce time to detect and time to resolve, provides actionable and high-value insights that drive the operational excellence. Let's see some examples of friction. So let's say if we use QuickSight for real-time monitoring, right? So QuickSight is not a real-time tool that we can use. So using QuickSight for real-time monitoring, definitely there is going to be a lag. And it is due to the nature of QuickSight batch processing approach that it makes it unsuitable for time-sensitive monitoring. And scaling CloudWatch logs without structured queries. Querying challenges due to unstructured log data leading to reduced visibility and insights. And overlapping tools without integration. So too sprawl causing fragmented data and complexity, and it hinders collaboration and efficiency. Friction arises when tools are misapplied, architectures fragment, or signal overwhelm teams. So it leads to delays, confusion, and higher costs. So what is the role of AIs in observability? So today there is a lot of hype about Gen AI, and it definitely has a role in observability. So one is predictive analytics to forecast issues. That's more of machine learning. So we use machine learning to predict problems and system failures before they occur and enable proactive remediation. And automated diagnostic to suggest root causes. So we can use the AI powered analysis of logs, metrics, and traces to quickly identify root causes of issues and can help accelerate troubleshooting and resolution. And we can also use natural language processing to simplify inserts allow users to ask questions about system performance and behavior in plan. So it'll help us generate tailored visualizations and reports. And then smart alerting to reduce noise. So we use machine learning to intelligently filter and prioritize alerts to reduce alert fatigue and ensure teams focus on most critical issues. So Gen AI or machine learning, when it comes to observability, they add predictive foresight, accelerate diagnostics, and enabling simpler, more intuitive access to the insights. So earlier when we discussed function versus friction, we discussed and understood how choosing the wrong tool can impact overall objectives, right? So here we'll discuss some of the common pitfalls and how we can mitigate them. Siloed tools. So observability tools that are not integrated leads to fragmented data and reduced data visibility. So it will cause fatigue, overwhelming number of alerts, distract and desensitize teams, and they'll hinder effective response. And reactive troubleshooting, relying on manual, time-consuming process to diagnose and resolve issues rather than proactive prevention. And addressing these common pitfalls upfront ensures observability and strengthens the operation without overwhelming teams through centralized pipelines, automated alerts, and design time observability integration. Coming to best practices, so it's important to implement observability early. Always incorporate observability capabilities into your architecture and design process from the start rather than bolting it later. So align SLOs and SLIs, service level objectives and service level indicators to the business goals. Ensure observability metrics and targets are closely tied to the KPIs that drive the organization's success. It's very important. And leverage automation wherever possible and machine learning. Automating observability tasks like alert generation, root cause analysis help optimize and improve efficiency and accuracy. And last but not least, focus on continuously improving, reviewing, and optimizing the pipelines. So regularly assessing the pipelines, tools, and processes to identify areas for improvement and ensure they remain relevant. So observability thrives when baked into the architecture. So aligned to the business value, consistently refined for efficiency and relevance. In this slide, we'll talk about real world use cases. Various use cases are applicable for, I'm just discussing a few of them, which is manufacturing IoT. So help monitor sensors, trigger predictive maintenance, optimize uptime. So for financial platforms, trace transaction, detect fraud, and monitor SLAs. E-commerce, track conversions, right? So monitor customer journeys, A/B test performance, many other things. Real world example shows how observability drives operational, financial, and customer outcomes from factory floor to the online storefront. So, in summary, observability enables scalable, resilient, and reliable systems. It's very crucial for modern data and cloud native systems. It will enable teams to maintain reliability, performance, and trust. And so AWS offers powerful suite of observability tools like CloudWatch, X-Ray, Grafana that provide diverse perspectives on system health. And from a best practices standpoint, we can definitely leverage Gen AI to a strategic advantage. By following observability best practices and leveraging power of AI and machine learning, organizations can bring a strategic advantage through real-time insights, predictive analytics, and automated response. So it is very important for modern cloud-native system, and AWS provides a comprehensive observability tool sets, and by combining it with best practices, that latest AI/ML capabilities. So, yeah. So finally, as we conclude, so observability in AWS, it's a very, not just AWS, but any cloud offering, it's very important. It's a very crucial capability for modern data architectures and solutions. It enables teams to maintain reliability, performance, and trust. And using some of the approaches, recommendations, and best practices, We can build scalable and resilient and reliable systems that can drive strategic advantages through real-time insights, predictive analytics, and automated response. Thank you.